All right, let's go ahead and get things kicked off here, everybody. Thank you all so much for making the time here to attend today's session. This is actually something I kind of threw together kind of at the last minute in the sense of scheduling this last week as opposed to scheduling it weeks or even months in advance. I had a customer of mine who had a bunch of questions about stored procedures and functions in Postgres. I've been using Postgres since the late 90s, and it's been around for a long time, and you just kind of assume that everybody who at least is using Postgres is familiar with these things. But the truth is, all of us are learning new technologies or technologies that are new to us, every single day. And just because something's been around for a long time doesn't mean we have a lot of experience with it. I even found for myself going back and reviewing some of the content for today, especially for some of the ways that I make use of these stored procs and functions, there were even a few little things I refreshed myself on. So I think this will be a great little topic for us to talk about here over the next hour or so. I know for a lot of these sessions, I make them for like an hour and a half or 2 hours, but because we kind of did this at the last minute, I decided to kind of limit this to an hour. I'll do my best to keep everything within that hour time frame to respect your time. But if we do go over and you have to drop off, just know that this will be posted up to YouTube later on today, at the latest tomorrow morning, but it should be later on today. I'll get this posted up to YouTube, and you can go back and watch whatever parts you missed because you had to drop off. So with all that said, let's go ahead and jump in here to our next session here on stored procedures and functions here in Postgres. As I do at the beginning of all of these things, just a couple of things about our programmer to programmer training series. So we started this kind of back in April, doing essentially free training sessions, sessions that in many ways are similar to the actual corporate training that I get paid to do on a regular basis. I wanted to try to take some of that content and bring it out to the larger community to, kind of benefit everyone, whether you work for a large company or not. So the goal here for our session is to deliver some of the same high quality training that you'd find in a big corporation training program. Deliver the training to everyone who has a web browser and an internet connection. Now, for today's session, you won't be able to code along with me as we usually do, but I'll explain why that is once we get over to the actual content. And of course, we want to focus in on languages and frameworks that are actually being used today by companies so people can hopefully take the training and help boost their career with it. Also, we want to empower people to be able to work where they live. People shouldn't have to travel all around the globe to do programming. That's a great thing about the internet. So by delivering these training classes and being able to do so for the most part with just the web browser and the internet connection, it allows people to take these classes and program and thrive and grow where they're located. And then of course we like to employ some AI tools along the way. I'll talk a little bit about using Copilot to help you with Postgres type programming as part of today's session. If you want to connect with us, here's our information in the chat here real quick. I'm going to put a link to our Discord group. The Discord group is where you can go and ask questions about anything that we talk about here once the session is over. So if I don't get to your question today, or you don't think of a question during the session and you have one later, go to the Discord group, ask the question there. I'll be more than happy to answer it. And of course, I've got links to the website and email and LinkedIn and stuff like that if you want to check any of that out. Okay. Our next two upcoming sessions, you see these are a little bit longer. We have next Friday, we're going to take a look at building web apps with Rust, Actix Web, and HTMX. As you all know, the bulk of our trainings we've done so far have all been centered around Rust. So this will be taking a look at building full stack web apps with Rust, but instead of using Leptos and WebAssembly for the client side coding, we're going to focus in on an up and coming technology called HTMX, which kind of gives you that same type of single page application type of feel for the end user. But instead of you writing a bunch of JavaScript code, most of your code is still running on the server, but HTMX does that automatic updating of the DOM tree for you. So we're going to take a look at combining that together in a training session next Friday, and that'll be for 2 hours. So that'll be a pretty long one. And then in a few weeks, we're going to do understanding PostgreSQL queries and indexing. So I remember back when I was first learning relational databases back in the 90s, I didn't always completely understand how queries and indexing and performance were all kind of tied together. And so we're going to take about an hour and a half to kind of go through that as it relates to Postgres. I would imagine a lot of people who are new to Postgres, this is probably something they struggle with as well. And so we'll take some time here in a few weeks to go over some content to explore that as well. We do offer customized private training. I really haven't highlighted this in our earlier sessions, but I'm starting to kind of push this a little bit more now. Most of the training classes that I teach are sold through third-party training companies, but now I'm starting to do more direct stuff myself. And so these are 2 classes that we have that are kind of related to the training we'll be talking about today. PostgreSQL for Python programmers. We could also do, Rust programming and stuff like that too, as well as the actual 2-day course, which this content was kind of pulled from. We have an actual 2-day class that goes much more in depth on these topics. If you or your team are interested in this, you can reach out to us. Be more than happy to talk to you about it. Okay, a couple of things here before we jump into the learning. First of all, thank you for registering and attending. Review the demos from today's training session. If you've got any questions, feel free to go over to Discord and ask over there. I'll be more than happy to answer them. Within 72 hours of the event, I'll have the recording uploaded to YouTube. I'll send you a link to the repo, and a badge will be sent to you with the email that you registered with. It shouldn't be 72 hours. I'm planning on doing it right after the session today, so you should get it today, but technically 72 hours. Follow us on LinkedIn if you want to stay up to date on future events. LinkedIn is probably the #1 way I promote events to the general public, and then of course I have the mailing list, and many of you all received the email, and thank you for reading that and signing up through it. And then at the end, I'm going to have a quick end of class survey. I know surveys are a pain, but your feedback on the survey is helpful to me for planning future sessions and some things that I've got in the works. And for those of you who have offered suggestions in the past, if you haven't quite seen them, come to reality yet, don't despair. I do have some future plans coming up in the works, things like office hours and stuff like that. It's just a matter of, I'm one person figuring out all the timing and everything to put those things in place. All right, so quick little overview. What is PostgreSQL? It's really just an open source relational database management system. So if you've got experience with SQL Server or Oracle, it's just really an open source version of those databases. It's been around for many decades. I started using it back in the 90s with my Perl and PHP programming. It's a fantastic database to use, and it's become even more popular in recent years, especially in the cloud computing world. And there's all types of extensions you can do and incorporating it into things like generative AI and with the vector extension. Also too, with no licensing fees, it's definitely a popular alternative to SQL Server and to Oracle. If you haven't really checked it out before, you're just joining today's session to kind of see what Postgres is all about, I'd highly encourage you to check out the Postgres database. It's really awesome. Okay, let's go ahead and jump into our coding here. So here is the repository for the session today. I'm going to drop that into the chat. By the way, I'll mention this. If you have any questions and stuff along the way, put them in the Q&A. I might see them in the chat, but the Q&A is the better place to put them in Teams here. Okay, so this repository has all of the code and demonstrations and stuff that we're going to be doing. As you all know from our prior sessions, I'm a huge fan of GitHub code spaces. Ordinarily, I would have you fork this and make a code space. The problem is that we need an actual running database. And unfortunately, I was not able to get GitHub code spaces to work with Docker Compose to actually run two containers, one for the coding and one for the database. I'm still working on that process. I'm sure it's something that I'm doing wrong on my end. So what I ended up doing was setting up a database up in the AWS cloud using Amazon's RDS feature. I've got a Postgres database up there that I'll be using for the demos. In order for you, though, to run the code, you have to have a Postgres database with all the data loaded and everything else. Obviously, we're not going to be able to do that within our little short 1 hour time period here. So what I did was on the README file here, I have some instructions that you can follow after the course to get yourself a database up and running with Docker, and then how you can go about using the DVD rental data that I'm using underneath the data folder, and how you can pull that into your database and then walk through the demonstrations. So you can do that on your own time. Afterwards, I've included instructions here for you to help you do that. Okay. With that said, let's go ahead and dive into our content. So what I've got over here is my code space that I already have set up here. And I'm going to walk through some SQL demos. We're also going to walk through some Rust examples of connecting to the database and doing some of these functions and stored procedure type operations. Before I do that, though, I want to highlight something here. I've included in the repository here a bunch of markdown files under the docs folder. In fact, it's better to kind of look at it from over here if we do it this way. And what I've done is I've provided here some documentation that you can read through that actually goes through and breaks down some of the syntax details and stuff like that for working with functions and stored procedures. When do you choose one over the other? How do these things factor into PostgreSQL's query planner? We're going to touch on these things as we kind of go through the demonstrations, but I won't be able to hit on every detail. So you can come over here to the docs folder and you can read through these. And this will be a great way to kind of jumpstart your learning on this topic, especially if you really are new to working with functions and stored procedures in Postgres. Okay, so with that said, let's come on over and take a look here at our code. So under SQL demos, I've got two folders. One is called functions. It has our functions demos, and then one is called stored procs. Now, in order to access our database, I'm using an extension here called SQL Tools. And what's cool about this particular extension is I can connect to Postgres with it. But right here inside of code spaces, inside the browser, I could come over to category, for example, and say show table records, and it pulls back all of my data. I can also come into here and I can run my database query. So for example, I can do select films here, and I've got this little run icon here at the top, and it will run the queries and give me back the results. So keep in mind, I am in code spaces in a web browser using VS Code, not just for coding and running stuff, but using this database extension. The extension that I'm using, you can actually find it here in the dev container JSON file. It's this MTXR SQL Tools, and of course it's got the Postgres driver. It works with multiple databases, but we're using it here with Postgres. So if you have an interest in doing this within VS Code or doing this within code spaces, that's the tooling that I'm using here to make these queries. Okay, so with that said, let's talk about functions. So functions and stored procs within databases are nothing new. They've been around for many decades now. What they basically allow us to do is to take logic, put it into some type of container, reusable container, and execute it. Now, by container, I don't mean like a Docker container. I'm just using container in a very general sense. So if you think about it, when most of us learn how to connect to a database and execute queries against it, we write these individual little SQL statements. We might even write more complex SQL statements like this. So if you were to open up your programming code, you'd open it up and you'd see all of these selects with joins and everything else right there in the code. And that can make things really, really messy. And it's not necessarily always as efficient for the database to take those SQL statements that you're crafting directly in your code and then try to execute them. So that's where functions and stored procs come in. Instead of having long SQL statements or multiple SQL statements kind of spread all throughout your Python or PHP or .NET, whatever code base, you can take that functionality and you can put it into these functions and stored procs inside the database. So for example, taking a very simple example here, selecting all the films, I could create a function that would come in and select the films. I could pick what columns and stuff I wanted, and then I could return back that result from the function. So then if I wanted to call the films, now I can get back whatever particular kind of data I wanted. Okay, so here inside my function, I'm controlling all the different fields and stuff that I would want to receive back. Over here in this query, I just did a select star, but I could have taken all of this, come back over to here, and every time I wanted these films, I'd have to repeat that list again and again and again and again. But if I take that code and I put that inside of this function here, now I can just call the function in the future and it can give me back that specific data. So the idea here is taking all of these details, pulling them out of your PHP or Python code and putting them into something like this that's then defined on the database itself. Now, what's interesting about Postgres, especially for those of you who, let's say, might come from a SQL Server type of background, is how Postgres kind of looks at functions versus procedures. So functions have been around in Postgres for a very, very long time. Stored procedures are much newer. Most of the time when people think of working with functions and stored procs, you think of using stored procedures for basically running code that produces side effects, like modifying data in the database, doing things that require transactions, returning back data sets, things like that. When you think about working with functions, you think about code that doesn't change data in the database, code that doesn't need transactions, code that is really just computing a value. That's how you think of functions. Well, Postgres, because of its history, the waters here get a little bit muddied between functions versus stored procs. For most of Postgres's history, functions have been the primary way that you would take this kind of logic and wrap it up into something that you could call from the database. And functions, in addition to returning values, could actually also make changes to the data in the database. Now, like I said a second ago, typically with functions, you don't make changes to the database. But in Postgres, before stored procedures existed, people would use functions not just for calculating and returning values, but also for making changes to the database. Stored procs, on the other hand, as I mentioned, are used when you've got multiple statements, you want to have transactions, you want to change data. In many database platforms, stored procs also return data. In Postgres, Stored procs can return data, but it's not as easy as you might expect it to be. Stored procs are really designed for just running multiple statements in transactions and modifying that data. If you're really trying to pull something back from the database, then Postgres really tries to push you towards using functions. The problem, though, is what if you want to modify data and get data back? That's where things become a little bit less clear when working with Postgres. In other database platforms, it's more clear, but because of the way these things developed in Postgres, it's a little bit less clear. What we're going to do here for our discussion is I'm going to focus in on functions not changing anything in the database, just returning data to us. And then for stored procedures, I'm going to focus those in on changing data in the database. And then if I want to get a value out of the procedure, I use something like an out parameter to do that. We'll kind of take a look at things kind of in those two different lights. Okay, so continuing on. We have this query here for selecting customers. If I wanted to package this up and make this more reusable, I have two ways I could do this. One, I could change this into a database view. A view is basically nothing more than just a query that the database, in a sense, has memorized, and basically gives you the ability to query off the results of that query through what's called a view. So a view would be a natural way to express this query, but I could also express this query inside of a function. What would be the benefits to using a function? Well, if I had some more complicated logic to pair with it, if I had certain special ways that I wanted to handle parameters, if there were additional calculations that I wanted to perform on the data, I could even take this and put part of it as a view and then have that view called by the function. So you have a lot of different ways that you can work with this. Because our focus here today is talking about functions, we're going to take a look at how to take this query and basically wrap it up here into a function. So let's take a look here at this code, and let's take a look at the function that we're working with. So first of all, you'll notice that the syntax here to create the function starts off with create or replace. Essentially, this is a convenience so that when you run this code over and over and over again, it'll let you update that function as you're modifying it without having to drop it. But there's an important thing you have to be aware of. If you modify the return type of a function or even a stored proc, if you modify those out parameters, create or replace will not work. You will have to drop the function first, then create it again. So create or replace will only let you update so long as you don't change the return type here. Now, the return type that we have is we're going to return back basically a table of data. We're going to return back a bunch of rows. And you can see here, I have my columns for my rows defined here, everything from the customer ID to the first name and address and city and postal code. And you can kind of tell this is a little bit older of a database because we have all these character varyings. A lot of times now we just use the text type, but that's okay. As we come down to here, you'll see that we have this double $sign. And this is indicating the code body of the function. So one of the things you'll notice with older technologies is sometimes they have kind of weird syntaxes. The way that people design languages now and the way they designed them, decades ago is a little bit different. I don't know if I was designing a new relational database and a new SQL language for that database that I would use $signs to indicate the start and end of the function body. But like I said, Postgres has been around for a long time. That's the kind of syntax you'll come across here. So don't let the $signs throw you off. There's nothing magical about it. It's just the way that Postgres represents the beginning and ending of the code block. You can see here we have a begin and end statement, and then we have our content here inside of the actual function itself. At the end, we have the language identifier. You can write functions in other languages within Postgres. There are some extensions for Perl and TCL and things like that. But we're going to use PL, PG, SQL in case you're curious. The PL stands for procedural language, and then the PG stands for Postgres, and then the SQL or SQL stands for structured query language. So that's where the name comes from there. If you take a look here at the actual code, we have this return query, and then we've got the select statement that does all of the column selections as well as all of the joins for us. So the nice thing about this is instead of writing this code over and over and over again in my application, now I could write this code in my application, and all of these joins and things would all be handled for me. Now, don't get me wrong, we could have also done this with a view, but like I said, our focus here is working with functions. So this is what it would look like to work with a function, and now I can pull this data back. So now if I were to run this, you can see now I get back my customer data, address, city, postal code, and country. Okay. All right. Let's take a look at another useful way of working with a function. So here, what I've got is I want to basically pull back the total amount of money that we made off of each film in the database. So we have the actual film table, which then connects into inventory, rental, and payment. And then we can sum up all of those payments to kind of know how much money we made. So if I run this query, you'll see we get back a bunch of results here in descending order. So I guess Telegraph Voyage, none of these are like real movie names, it's all fake data. Telegraph Voyage, our total payments we made was $215 for rentals. So this would be another good example of something that I could drop into a function. So I take this, drop it into here, and once again, you can see it has a very similar structure as the other one did. So you can see making use of these functions is pretty easy to do. Once you understand the basic syntax structure, the problem that it solves for you, so on and so forth, you can create these things pretty easily. Now, what I really want to do is I really want to get the total payments for a particular film, okay? So for example here, where film ID is equal to 879. So if I were to run this, you'll see I get back Telegraph Voyage for $215.75. Now I can call this and I can get back all the results if I want to and then do my where statement. Or I could take this and parameterize my query. And so that's what you see happening here. I'm going to come into here and I'm going to parameterize my function, okay, with the film ID, and then I'll get my total payments here and store that in a variable. So parameters go up here inside of the parentheses for the function definition. You can also have additional variables declared as part of the function. Now you'll notice here the declare block went right before the begin. So you might have wondered earlier, well, if the double dollar sign means the start and the end of the function body, why was there like another begin and end? That wouldn't make a lot of sense, right? Well, that's because you can have other things in here like declare, where you can declare your variables. Now, most of us in our day-to-day programming, we're used to declaring variables where we use the variable the first time. But if you were to go back 30 years ago and before, when people would write programming code, not just functions for a database, but pretty much any language, you would actually declare all of your variables at the top of a function and then use those variables inside the function. So what you see here is, like I said, because Postgres has been around for a long time, you see this idea of let's declare the variables at the top, and then we can make use of them. The way that we assign the total payments value is we use this select into. The select into will take the result of this column and select it into our total payments here. And of course, we're limiting this to just one result that comes back. And of course, we have our conditional there using our parameter. And then we return back our total payments there for the film. So now when I call this, I could come into here and run this and get back my total payments for that particular film, and I can pass this value in. Now, what's cool about this is that I can take this query now and parameterize this from the perspective of the programming language that I'm using. So I thought it'd be kind of fun today to take a look at using Rust to call our database and do these queries. So we have our main file here, and what I'm going to do is just kind of uncomment this code here. There we go. And so let me open up the DVD rental. Now you'll see there's a bunch of hard-coded stuff here, like the hard-coded password. All of that will be removed when I push the final version up following today's session. Don't try to connect to the database. It's all locked down via IP addresses and stuff like that, but all the credentials and stuff will be removed. But what you'll need to do is replace this information with your own information for the database that you want to connect to if you want to go further with exploring this. Anyways, if we scroll down to here, let's take a look at how we would actually call this using Rust and SQLX. And even if you're not a Rust programmer, all the ideas and principles we're going to talk about here apply to like every other language that you've ever worked with in terms of doing parameterized queries and things like that for calling the database. So if you take a look here, we've got this select statement. Now, the way that SQLX works and the way that my Rust data types are going to work, I'm going to have to incorporate this cast function to cast the result here to a float 8 in order to be able to get my total payments value and be able to assign that back. So if you're looking at this like, oh, what's that weird cast thing about? That was just something I had to add to make SQLX happy for the little Rust application here. But you can see there's a $1 here, which is indicating a parameter, right? Doesn't matter really which database library you use. They all have some type of convention for saying, oh, this is a parameter that will be replaced with an actual value. But notice I don't just stick the value in there with string concatenating and stuff like that. We use the whole parameterization mechanism, which in this case is going to be the bind function that you see here. So we're going to take that film ID, we're going to bind it to the parameter on our select statement, and then we're going to fetch back our data. And then off of that, we're going to get our total payments. So if I were to come into here and go into here, and by the way, if you do use the code space, this code space is fully configured for Rust. So once you create the fork of the repo, create your code space, open the terminal and change into your project, all you'll have to do is do like a Rust build or not Rust, cargo build or cargo run, and you'll be able to actually run all of this. So I'll do a build real quick, make sure it all builds. Cool. And I can do cargo run, and we should get back 215.75. So if you've ever been considering using Rust to connect to a Postgres database, I like using SQLX. It's the one that I have the most experience with. Works really, really well. I've had a project here recently that I've been working on using the vector database extension for Postgres and doing some generative AI RAG type of stuff with some content that I have. And Postgres has worked really well for it, and Rust has worked really well for it too. So if you've never explored Rust with Postgres, use these demos as kind of a starting point to get launched in that direction. Okay, so that's the basic idea there behind functions. One thing I want to mention before I jump over to stored procs is in the docs here, I've got a section on functions. Actually, this is the one that I want right here. that talks about immutable, stable, and volatile functions. If you want to get the best performance for your functions in general in Postgres, take a look at this document here and take a look at the difference between immutable, stable, and volatile. They factor into how Postgres chooses to execute these queries and can really help with performance if you apply the right attribute to the function and tell Postgres how this function is really kind of working. You can get better performance. And you can get to that document just underneath the docs folder on your own time. Okay. So yeah, I can share let me give you the link to the repo real quick. I've got a person requesting here. So there's the link to the repo. The code space, you'll need to fork it and create your own code space. But you'll need to do that after today's session because you'll need a Postgres database up and running to run the demos. I've included the instructions to create the database and all that here inside the README. But you'll need a database to run any of this. So for right now, just watch the demonstrations. But yes, once this is over, create a fork of the repo, create a code space. All the details except for the database part will be up and ready for you to make use of. Okay, let's continue on here. Let's move over into stored procs. Okay, so stored procs are used to essentially do operations that modify data. Now, typically, it's usually multiple SQL statements. Many times, you're wrapping these things inside of transactions and stuff. But stored procs are really all about modifying the data on the database. About 25, 30 years ago, there was a major push in the programming world to take the business logic of applications and move it into stored procs on databases. A lot of the contracts and stuff that I worked on 25 years ago, as part of the regular programming we would do, we would spend a lot of time writing SQL code, implementing all of this business logic directly in the database. Now, the reason why it was done back then was it was probably better performing, but it also caused people to get locked into database licenses. Well, with the advent of the cloud and the advent of scaling up applications to handle large numbers of users, storing all of that business logic inside the database is not only expensive in terms of paying licensing fees, but storing all of that logic in the database doesn't scale up very well. So what happened was, as a result of the cloud and scalability and licensing concerns, there was a big push in the industry over the last 15 to 20 years to basically move away from stored procedures. So the idea was, well, we put all the business logic in stored procs and that proved to be a bad idea. So let's keep all of the logic in the application and not use stored procedures at all. And of course, that's also kind of going, too far in the other direction. Stored procs are not the proper place for business logic, but stored procs are the perfect place for your database logic to go. And there is a difference between database logic and business logic. Okay, database logic and business logic are not the same thing. A lot of times people struggle with how they're different, but they're not the same thing. If you look at a sufficiently large and complex application, you will notice that data is stored in the database in the way that's most efficient for that database platform, but that doesn't necessarily align with how the business logic is organized. And so we don't design business logic for the database. We don't design the database for the business logic. So there is logic that is truly oriented for the business, and then there is logic that's oriented for how we optimize how we're storing and retrieving things in the database. That logic that's optimized for storing and retrieving things from the database, that's the code that you put inside of the stored proc. So for example, the business logic might be, I want to add a customer to my DVD rental system. But the database logic to do that might be insert an address record, insert a customer record, things like that. So the business logic is a new customer, but the database logic is multiple insert statements into different tables. Those multiple insert statements are not business logic. And if you can put them together in something like a stored proc, that's a good way to go. So I just want to throw that in there because I think sometimes there's confusion about what is business logic versus what is database logic. In database logic is what stored procedures really excel at. So let's take a look here at this first little example. Once again, you'll see that create or replace mechanism. As long as your output parameters, which I haven't shown you yet, don't change, you can do create and replace. But if your output parameters change, you do have to drop the procedure before creating and replacing the new version. You can see here, I've got a name for it, insert category. I've got a parameter for it. The language goes up here at the top, and then we've got that same type of syntax you'll see here with the double $ in the begin end. So the nice thing is the procedure syntax is similar to how we work with functions. And of course, all I have to do here is put my insert statement for inserting my category here into my database. Now, the way that you call the stored proc is with the call keyword. So with functions, we incorporated them into a query, and they can be incorporated as part of a select statement, part of a from statement. But here, for the stored procs, we use the call syntax to call them. So if I were to run this, you'll see, let's see here. Oh, do I not have that created? Let's create that. I think I actually might have replaced it with a different one. Let's go ahead and run that. Ah, see, cannot change whether a procedure has output parameters. I modified it down here. We'll keep pushing through, but this is the basics of the insert category and how you would call it. I have a more sophisticated version a few demos down. Okay, let's take a look here at deleting a category by name. So here I have a I've got a stored proc which is going to delete a category by name. You can see that I would pass into the procedure here the name parameter. I also have myself a variable defined here, and I'm going to come into here and select into that variable the category with that particular name, and then we're going to delete that from the from the database table. So here I've got one query that gets the ID, and then that one that does the delete. And I'm going to throw in a limit 1 there. And let's see if I can recreate that. That's good. So see how I was able to modify that and recreate it? As long as I don't change anything about the output parameters, you can do that. So now if we come over to here, let's call this and delete new category. Now, if we come over to our database here real quick, and I come over to category and say show table records, I think I've got a number of new categories in there. So let's come into here and let's run this. And we'll run this a few times. And so now if I come back over to here and I rerun my query, you'll see I'm down to just having 2 categories now instead of all of these. Okay. I'm not going to delete them all because we're going to take a look at our next little demo. That's just kind of the basics there. Multiple queries and then calling to do our deletion here. Now, this is the part I really wanted to talk to you a little bit about here with these stored procs. One of the things you can do with stored procs is you can output information about if they were successful. You can throw exceptions and things like that. People don't always think about that when coding up stored procs, but I'm a huge fan of if I've got this database logic in a stored proc and something goes wrong, or there's some type of information I want to make the caller aware of, I like to be able to do that. So for example, here, let's say I go to look for the category I want to delete, but I don't find it, right? So let's say we come back over to here, and I'm going to run, hold on one second. All right, so I'm going to come over here, I'm going to run this. And so we're going to get the new version with the raised notice. And let me throw in my limit 1 here as well. Okay, so I've updated that. Now what I'm going to do is call my delete category by name. And I'm going to come over to SQL Console, is the tool provided by the extension for seeing the results. So I'm going to run this. Okay, see how it says category with name, new category, and ID 28 deleted? That is coming from right here with this raised notice. See how I'm seeing that in the SQL console as part of the output? Now, I'm going to run this again, and you'll see it deleted. I will run this again, and you see how it says category with name, new category not found? So in my code here, I was able to take into consideration whether or not we even found the category that we wanted to delete. Now, some people would say, well, there's no need to notify about this. If it's not there, it's not there. But I sometimes take the approach of if I'm intending to delete something and it's not there for me to delete, there might be a larger problem. So this would be a way that I could communicate back to the caller, hey, this category was not found that you wanted to delete. Now you can kind of take this to the next level, and you can actually have it raise an actual exception. So for example, if I ran this right here, so let me update the procedure again, and then I run the delete operation. Now, this time, I had an error. Category with name, new category was not found. I actually had an error occur trying to delete that category. Well, up here in my Rust code, so if I go to Rust SQL X stored proc and go to the main method here, if I try to delete this category by name and this category doesn't exist, I can actually catch that exception as an error inside of my Rust code, just like I'd call another Rust function and it returns back, the error variant of the result enum. I can get that same experience here calling this code. Okay, so down here, when I actually call the delete here, if this fails, right? So there's my call, delete, and my parameter. If this fails, that error is going to be what's returned to me up here. So if I were to come over to the terminal and go to stored proc here and then do cargo run, you'll see this is the error that I get back. A database error occurred, and then these are all the details. So for example, I probably would take this and log this out. This might return this to the user. So if I were to run this again, when the user runs it, they just see a database error occurred, and then I can take that error and log it out somewhere. But the cool thing is I was able to raise that exception from the stored proc and handle that in my Rust code. And you're not limited to only handling exceptions in Rust. If you're doing Postgres, C#, Node, whatever, Python, you can handle these exceptions as well when the operation fails and have a way of logging, but also a graceful way of presenting information to the user. Now, the last one I wanted to take a quick look at here was being able to output data from a stored proc. Now, to be honest with you, this is awkward. In other databases like SQL Server, Postgres and SQL Server are probably the two biggest relational databases that I use a lot. Over the years, I've done a lot of stuff with Oracle, back when Sybase was a thing, MySQL, stuff like that. But in terms of the two that I use the most now, it's Postgres and SQL Server. In SQL Server, the way stored procs work over there is they make it very, very easy to return back data from a stored proc. Postgres, not so much. I'm going to have to use this output variable here. And in this case, we're going to have an insert category stored proc, and it will insert it. The reason I'm using a stored proc is inserting changes the underlying data. But what I want to do is output that category ID and be able to see what that ID looks like. Now, to call this is actually a little bit more awkward, because in order to get that output variable, I have to have a variable to pass into the stored proc. So here I've got an anonymous code block where I declare a variable, pass it into here, and then when I run this, I can see the new category ID. So if I run this, we should be able to come down to the SQL console, and there's the new category ID. So I was able to get that through an out parameter, but you can see it's definitely a little bit more awkward, especially just trying to run some plain SQL here. Well, how would this look inside of our Rust code? So in the Rust code, I call the stored proc the same way I did before, except that I don't pass in a variable, I pass in null. So when you call a stored proc with output parameters and you don't want the value of the output parameter, you can pass in null. And that's true not only for this Rust code, but it's also true for just writing plain SQL. The thing though is I actually do want the output parameter. Unfortunately, I can't do some type of binding of a variable to an output parameter. So I'm going to have to call this passing in null for the output. But then what I can do is, instead of doing a straight up execute like we did before for delete category by name, I'm going to do a fetch one query. Well, it turns out the result, those output parameters actually come back as like a row of results that you can then work with. So using fetch one, I'll get back the row, which will include the output parameters. And so here I'm referencing that output parameter and getting the ID of the new category that was added. So if we came into our main code here and I run this, now I can call my insert category and return ID and actually get the ID back because of the code that we have here. So if I were to come in here and run this now, you'll see new category ID 31. So when it comes to working with stored procs and getting data back, it is a little bit awkward, a little bit of extra work you have to do, not just in terms of a language like Rust and SQLX, but also writing queries themselves. Okay, we have literally just a minute or two here to go. A couple of things before we take off. Number one, the repository will be up here pretty much forever. So you can come back and check out the examples. If you want to use the code, remember to fork it first, then create a code space off the fork. You will have to have a Postgres database up and running. If you already have one you can connect to, then just use the information for that database. If not, there are some instructions down here in the README which will go over how to get a database up and running with Docker, how to connect to it. If you are connecting to a cloud database and you need to connect to it from code spaces, most of the time for cloud databases, we limit access based upon IP address. So if you've ever done remote work before and you've had to go into your cloud-based, database system and put in your IP so you can then use your client software, that same issue exists here. I've given you a command that you can run on the code space to give you the local IP. If you take this IP and put it into the firewall configuration on AWS or Azure, you'll be able to call that database from your code running here. You'll also be able to call the database from the extension tooling that we have over here. So just kind of keep that in mind. All right, let me double check to see if we've got any questions from anybody here before we wrap things up. Okay, cool. All right. Well, thank you all so much again for attending today's session. We do have some upcoming sessions. If you'd like to attend those, we would love to have you. As soon as this is over today, I'm going to start the process of distributing badges, uploading the recording and stuff like that. Give me a few hours to get that done. If you have any questions about anything, please do not hesitate to join the Discord group and offer comments there. Okay. And I'm more than happy to take questions and stuff over in Discord. The reason why we do it on Discord, or the reason why I want to do it on Discord, is so other people can benefit from the discussion. Okay. So just head over to Discord if you've got additional questions. Other than that, thank you again, and I look forward to seeing you all again in a future programmer to programmer training session.